Hello everyone. So now we will continue with the decision tree model. Now we need to figure out what is pending from the previous video, which is how we actually choose the best variable. So for example, in our previous tree, how we can figure out what could be the variable chosen as root node in the beginning, client history or income. Okay, so the first thing we want to figure out is how to measure the score or the quality of a variable. And it has to relate somehow the variable with the class we want to predict. So for example here, how we could measure how good is the variable income to predict the class client type. We can see that one intuition is that if we take a look to the values that the variable income takes, we would like to see how the class changes according to changes in the variable value. In other words, it's like when we move from one value to a different value in the variable income, is the class changing also? Another intuition is that we can see that one variable is good to separate the class when we see that most of the rows that relate the same variable of the given variable end up in the same value on the class. So in the previous slide, we saw that we want that for changes in the variable, we have also changes in the class. But now here we want that when we do not have changes in the variable, we hopefully have the same value of the class. So how to decide, for example, if one variable is better than another? Let's take the example of the variable age. We can see that age takes two different values, between 18 and 25 or older than 25. So let's separate the rows according to those values. We can use colors here. And then we take a look to the values of the class according to that separation in the variable age. So in this case, when age is between 18 and 25, we get one frequent and one occasional case. That's not good, right? Because for the same value, we have a confusion of what is really the class of those cases. And now let's take the other possible value. When the age is older than 25, what happens? We get, again, one frequent and one occasional client. It means that also we have confusion. So if we use the variable age, we cannot decide what is the class of the client. So now let's analyze the variable gender. In this case, we have two values for gender, right? And we can divide them according to the rows. So for man, we have two frequents, and for woman, we have two occasional. So when the gender is woman, we get two occasional, and when it's man, we get two frequent. That is good, right? Because there is no confusion on the class when we instantiate the value of the variable gender. As a conclusion, the variable gender is better because we could separate the class in homogeneous groups. But in the case of the age, we couldn't do that because when we separated the class according to the value of the age, we got groups that have not homogeneous values in the class. So let's see another example. Imagine we have one database with two variables, two binary variables, and also one binary class that can take values yes and no. So let's assume that the first 50 rows have value yes in the class, and the last 50, they belong to the class no. Let's assume that when the variable a takes the value 0, we get 48 cases in the class yes and 2 cases in the class no. On the other hand, when the variable a takes the value 1, we get 2 rows belonging to class yes and 48 rows belonging to class no. That's not perfect, right? It's not a perfect classification, but we can see that most of the cases belong to one class and the other. On the other hand, imagine that for variable b, when it takes the value 0, we get 26 cases in the class yes and 24 cases in the class no. And when the variable b takes the value 1, we get 24 cases in the class yes and 26 rows in the class no. So that is not good, because here, when we instantiate the variable b in one of the possible values, there is sort of a big confusion, because roughly half of the cases belong to one class and the other half to the other class. So at the end, we can conclude that the variable a is much better than the variable b, because it allows us to separate much better among the classes compared to b, where we get a confusion. So we're going to use the entropy as a homogeneity metric. This is basically a formula or equation that, given a set of classes and all the rows on our database, we can get a number that is telling us how cluttered is our classification. So when we have more clutter, it means that there is more confusion, and that variable is not good to separate among the possible classes. The formula, it is basically going over each of the possible class values and is summing the proportion of cases in that class times the log of the proportion of cases in that class. And at the end is multiplied by -1. So let's see an example. Let's calculate the entropy of the class in this case. So we need to separate here the possible classes. And we can see that we have 3 cases in occasional and 1 case in frequent. So according to the previous formula, we need to go and sum the proportion of each of the classes times the log. So in this case, it's going to be 3 out of 4 for occasional and 1 out of 4 for frequent. So we need to go and sum these proportions, multiply by -1, and we get that the entropy is 0.81. As a summary, the entropy function looks like this for 2 possible classes. So imagine that the classes are yes and no. In this axis here, we have the proportion of the class yes. So the entropy is maximum, it takes the value 1 when we have 50% of proportion. In other case, 50% of the cases belonging to the class yes and the other 50 to the class no. That is the worst case of clutter, because we have half of the cases in one class and the other half in the other class, and we do not want that. So every time we get high values of entropy, it means that we got confusion and we couldn't separate well among the classes. From the other side, when we get that the proportion of the class yes is 0, it means that all the cases belong to the class no. That is a good case, because we could actually separate, and then entropy is 0. In the other case, when entropy is 0, when 100% of the cases belong to class yes, again, there is 0 clutter, so 0 entropy, and we don't have any confusion about the class. It is 0 confused. It means that all the cases belong to class yes, and then we can easily classify. So this is going to be the main function that will be helpful for us to decide when one variable is good. And in easy words, we will go over all the possible values of the variable, and we will calculate and see how the class gets uncluttered when we instantiate that variable. And we are going to average over that. So if that average has low clutter, it means that that variable is good.